Hello, students. Today we will study about chemical reactions and equations part 2, in which we will study about decomposition reaction, displacement reaction, double displacement reaction, redox reaction, corrosion, and rancidity. Look around. Whenever you visit a pharmacy, you'll notice that medicines are stored very carefully. Some in bottles, some in airtight containers, and some with special instructions written on them. But have you ever wondered why? Let us see what is written on the bottles. These medicines are not just simple liquids or powders. They are chemical substances that can change if not stored properly. Some of them can break down into different substances when exposed to light, air, or heat. That's why we often see special storage instructions. For example, look at this label. It says, "Keep away from sunlight. Contents may decompose." But what does that mean? It means that the medicine inside can undergo a decomposition reaction. In this process, one substance breaks down into two or more simpler substances. And if that happens, the medicine may lose its effectiveness or even become harmful. Let us study more about decomposition reaction on the next slide. Decomposition reactions involve a single reactant breaking down into two or more simpler products. This process can be represented as AB, brought AB plus B, where AB is the original compound, and A and B are the resulting simpler substances. These reactions are fundamental in understanding chemical processes and transformations. Decomposition reaction has been classified into 3 parts. 1. Thermal decomposition. 2. Photolytic decomposition. 3. Electrolytic decomposition. Let us study about each reaction on upcoming slides. A decomposition reaction is a type of chemical reaction where a single compound breaks down into two or more simpler substances. When this breakdown is caused by heat, we call it thermal decomposition. Here, we are heating iron 2 sulfate crystals, which are written as FeSO4. At the start, these crystals are light green in color. When we heat them strongly in a test tube, the compound begins to break apart. The products formed are ferric oxide, written as Fe2O3, which is a solid substance, along with sulfur dioxide gas, SO2, and sulfur trioxide gas, SO3. The balanced chemical equation is 2FeSO4 on heating gives Fe2O3 plus SO2 plus SO3. During the experiment, you will observe that the green crystals first turn brown as ferric oxide is formed. At the same time, you may notice the release of sulfur dioxide and sulfur trioxide gases, which have a sharp and irritating smell. Photolytic decomposition reaction is coming on the next slide. As we have noticed, some medicine bottles carry a label that says, "Keep away from sunlight." But why is that? The reason is that exposure to sunlight can sometimes cause decomposition of the chemicals inside the bottle. Let us see the name of such decomposition on the next slide. Photolytic decomposition is a type of reaction where a compound breaks down into simpler substances in the presence of light instead of heat. For example, silver chloride, written as AgCl, is a white-colored compound. When it is exposed to sunlight, it decomposes to form metallic silver, which appears gray in color, and chlorine gas. The reaction is 2AgCl in the presence of light is 2Ag plus Cl2 gas. This is why silver chloride is always stored in dark or colored bottles to protect it from light. So, in the case of medicines too, sunlight can trigger photolytic decomposition, which is why they are stored in tightly packed, dark-colored containers to ensure safety and effectiveness. Next type of decomposition reaction is coming on next slide. Water, the most common and essential liquid around us. But have you ever wondered, can we break it down into its elements, hydrogen and oxygen, just by using heat or light? Let's think about it. If we heat water, it simply evaporates. And even under bright light, it doesn't split into gases. So if neither heat nor light can do it, how do we actually decompose water? When we pass an electric current through water, it breaks down into hydrogen and oxygen gases. The hydrogen gas collects at the cathode and oxygen at the anode. So, decomposition reactions that require electricity are called electrolytic decomposition reactions. 2H2O electrolytic decomposes to form 2H2 and O2 gases. Let us summarize decomposition reaction. Decomposition reactions are those where one substance splits into two or more simpler substances, like A decomposes to form B and C. And based on what energy we use to break it down, they are of three types: thermal decomposition, when heat is used; photolytic decomposition, when light is used; and electrolytic decomposition, when electricity is used. A question is coming on next slide. A volume of hydrogen gas evolved during electrolytic decomposition of water is times the amount of oxygen gas evolved. Pause and answer the question. During the electrolytic decomposition of water, the volume of hydrogen gas produced is twice the volume of oxygen gas. This is due to the stoichiometry of the reaction. 2H2O decomposes into 2H2 and O2, indicating a 2-to-1 ratio of hydrogen to oxygen gas. Next question is coming on next slide. Thermal decomposition of lead nitrate is an example of this reaction. Pause and answer the question. Thermal decomposition of lead nitrate is an endothermic reaction. This process absorbs heat, breaking down lead nitrate into lead oxide, nitrogen dioxide, and oxygen. The reaction is represented by the equation 2PbNO32 plus 2PbO plus 4NO2 gas plus O2 gas. We've understood about decomposition reaction. Now let us study about displacement reaction on the next slide. Let's perform a simple activity to understand a type of chemical reaction. Take an iron nail and a beaker containing copper sulfate solution, CuSO4. Place the iron nail into the solution and leave it undisturbed for some time. Observe the reaction as the iron nail is immersed in copper sulfate solution. After some time, color of the solution turns to green color, and iron nail color also changed. Let us see the reason behind this phenomenon. What you are observing here is a displacement reaction. These are chemical reactions where one element displaces another element from its compound. In this case, the iron, Fe, displaces the copper, Cu, from the copper sulfate solution. The initial blue copper sulfate solution turns into a green ferrous sulfate, solution FeSO4. Simultaneously, a reddish-brown layer of copper deposition forms on the iron nail. The chemical equation for this reaction is Fes plus manganese QSO4 aqueous equals Cus. Will the reversed reaction possible or not? Let us see further slides. When a copper rod is placed in ferrous sulfate solution, no reaction occurs. This is because copper is less reactive than iron, and thus cannot displace iron from ferrous sulfate. This highlights the importance of reactivity in determining whether a displacement reaction will occur. Next slide is coming to discuss about reactivity and displacement reaction. A more reactive element displaces a less reactive element from its compound. Think of it like a set of interlocking puzzle pieces. If C, the more reactive element, wants to bond with B, it will kick out A, the less reactive element, to take its place. The order of reactivity for common metals is shown below the diagram. As you move from left to right, the reactivity decreases. The reactivity series ranks elements by their ability to displace others: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. This hierarchy determines the feasibility of displacement reactions. More reactive elements displaces less reactive elements from its solution. Let us see in case of Fe and CuSO4 solution. Let us now observe the reaction between iron and copper sulfate solution. When a clean iron nail is dipped into blue copper sulfate solution, a reaction takes place. Gradually, the blue color of copper sulfate fades and turns green because ferrous sulfate is formed. At the same time, a brown layer of copper metal gets deposited on the surface of the iron nail. This happens because iron is more reactive than copper, so it displaces copper from copper sulfate solution. The reaction can be written as Fe plus CuSO4 gives FeSO4 plus Cu. What will happen when two metal salts react with each other? What will happen when solutions of two metal salts, such as sodium sulfate, Na2SO4, and barium chloride, BaCl2, react? Now, let us understand a double displacement reaction. In this type of reaction, there is an exchange of ions between two compounds to form new products. For example, when sodium sulfate solution reacts with barium chloride solution, the ions rearrange themselves. Barium from barium chloride combines with sulfate ions to form barium sulfate, which is an insoluble white precipitate. At the same time, sodium ions combine with chloride ions to form sodium chloride solution. So the reaction can be represented as Na2SO4 plus BaCl2 gives BaSO4 plus 2NaCl. This reaction clearly shows how two compounds exchange their ions, resulting in the formation of entirely new products. A question is coming up on next slide. A given chemical equation is an example of a question reaction. Pause and answer the question. The given chemical equation exemplifies a double displacement reaction. In this process, ions are exchanged between reactant molecules, resulting in the formation of new compounds. Here, potassium iodide and lead nitrate react to form lead iodide and potassium nitrate, showcasing the characteristic ion exchange of double displacement reactions. Observe the reaction 2Cu plus O2 gas equal to 2CuOS, C plus O2 gas equal to CO2 gas, and 2Mg gas plus O2 gas equal to 2MgOS. In all these reactions, addition of oxygen is taking place. Reaction in which addition of oxygen is taking place is known by some specific type reaction. Let us see on next slide. Let us now understand redox reactions. The term redox stands for reduction and oxidation, two processes that occur together in a reaction. Oxidation involves the addition of oxygen or the removal of hydrogen. On the other hand, reduction involves the addition of hydrogen or the removal of oxygen. For example, when copper oxide reacts with hydrogen gas on heating, copper oxide loses oxygen and gets reduced to copper. At the same time, hydrogen gains oxygen and gets oxidized to form water. So in this single reaction, reduction and oxidation take place simultaneously. What different types of redox reaction occur around us? Let us see on upcoming slides. Corrosion is a redox reaction where metals deteriorate due to chemical processes. Iron rusts when exposed to oxygen and moisture, forming iron oxide. Similarly, copper and silver tarnish as they react with sulfur compounds in the air, forming copper sulfide and silver sulfide, respectively. These reactions highlight the pervasive nature of redox processes in our environment. Other examples of redox reactions are coming up on next slide. Rancidity occurs when oils and fats in food oxidize, leading to unpleasant odors and tastes. Initially, food is fresh, but over time, exposure to air causes chemical changes. By day 20, the food develops a foul odor and taste, indicating significant oxidation. Understanding this process helps in preserving food quality and preventing spoilage. Identify the reactant that is getting oxidized in the given redox reaction. ZnO plus C is equal to Zn plus CO. Pause and answer the question. In the redox reaction, carbon is oxidized. It loses electrons to form carbon monoxide, CO, while zinc oxide, ZnO, is reduced to zinc, Zn. This process exemplifies the transfer of electrons, a key characteristic of redox reactions. Summary slide is coming up on next slide. Here's concise summary of the different types of chemical reactions you mentioned. Decomposition reactions. A single compound breaks down into two or more simpler substances. Thermal decomposition. Breakdown caused by heat. Example, CaCO3 is AO plus CO2. Photolytic decomposition. Breakdown caused by light. Example, 2AgCl. Breakdown caused by light in presence of sunlight. Example, electrolytic decomposition. Breakdown caused by electricity. Example, 2H2O is equal to 2H2 plus O2 by electrolysis. Displacement reaction. A more reactive element displaces a less reactive element from its compound. Example, Fe plus CuSO4 breakdown by FeSO4 plus Cu. Double displacement reaction. Two compounds exchange ions to form two new compounds, often producing a precipitate or gas. Example, Na2SO4 plus BaCl2 breakdown by BaCl4 precipitate. Redox reaction, where oxidation and reduction occur simultaneously. Oxidation is addition of oxygen, removal of hydrogen. Reduction is addition of hydrogen, removal of oxygen. Example, CuO plus H2 per second H2O. I hope you have understand about types of reactions. Please like, subscribe, and share this channel for more video. Thank you, students.